Hello students, how are you all? So now today we will start with our third law of chemical combinations. So now we have the third law of chemical combinations, law of multiple proportions. So in this law, I have told you now this law was proposed by Dalton in 1803. Okay, and according to this law, if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other elements are in the ratio of small whole number. Okay, that is the law. For example, let us take the example of hydrogen and oxygen. Now when hydrogen and oxygen combines together to form two compounds, namely water and hydrogen peroxide, as you can see in my board. So now hydrogen and oxygen, when it will get mixed, first form the water and second one is form the hydrogen peroxide. So in these cases, the composition of hydrogen remains same, 2 gram, and oxygen has been changed. Okay, now oxygen first, when we prepare a water, it will take a 16 gram, and now second is it has a 32 grams. So when we take as a 16 gram of oxygen, we will obtain a water, and when we add the 32 gram of oxygen, we will get the hydrogen peroxide. Okay, means two elements can combine to form more than one compounds. Okay, two elements, but they are combined in the fixed mass of the other elements. Means fixed mass means hydrogen has a fixed mass, but other elements there is no fixed mass of oxygen. So we will obtain the that particular compound are in the ratio of a small whole number, like 16 and 32. So here the masses of oxygen 16 and 32, which combines with a fixed mass of hydrogen 2 gram hydrogen, where a simple ratio 16:32, or it is said to be a, when we get converted it into simplest form, it is what we will obtain, the 16:32 is 1:2. Okay, now we will take the another example of our nitrogen oxides. So when we mix the nitrogen and oxygen to obtain the nitrogen, the oxide of nitrogen. Okay, but in cases, let's first observe, and there is a need to be know about the mass of nitrogen is equal to 14 and the mass of oxygen is equal to 16. So the first oxide is N2O. The ratio of nitrogen and oxygen is nitrogen of 2 moles means N2, we will take 28 gram, and ratio 16 is the oxygen. Now we will convert it into simplest form, so 14:8. And now again NO, N for means 1 nitrogen, it is a 14 ratio, 1 oxygen 16. We take a NO means 1 nitrogen 1 oxygen. So 1 nitrogen atomic mass is 14 and 1 oxygen mass is 16, and it remains same. And now again the N2O3. Okay, so now N2O3, N2 means we take the double of the 14, means 14 2s are 28 and 16 3s are 48. And what we will get after simplify 14:24. And now next N2O4, it is a 28:64. How will it get? Now N2O4 nitrogen 14 into 2 and oxygen 16 into 4, 64. Now in a see in your right hand side it is 14:32, and again in the 28:80 now we will obtain a 14:40. Okay, what does it means? When the masses of oxygen which combined with the fixed mass of nitrogen always taken a 14 gram, and as you can see in this picture the oxygen mass of oxygen will change, but it is a simplest ratio. How it is simplest ratio? 8 into 16, it's 24, 32 and 14, but it will get the simplest form like others. Now as you have understand now the here when we have the taken an example of water and hydrogen peroxide, it will get 1:2. Now here is also oxygen 8, and again 2 times the oxygen 16, and again 3 times the oxygen is 24, and 4 times the 32, and 5 times the oxygen is 40. Okay, now you can see in the right hand side 18, 16, 24, 32 and 40. So that's proven the law. Means if two elements can combine to form more than one compounds, the masses of one element that combines with a fixed mass of the other elements are in the ratio of a small whole number. So as you can see that nitrogen remains same by the masses 14, and oxygen will be changed. Okay, that is the third law of our laws of chemical combination. So the third law is laws of multiple proportion. Okay, and now next we will discuss one of the remaining two laws.